We must remember that physics is very simple. In this lesson, we are going to find the time period of a simple pendulum using restoring torque method. Physics is so simple that you have things like simple pendulum, you have chapters like simple harmonic motion. So now this is a simple pendulum and we want to find its time period using the restoring torque method. So this is the main position of the pendulum, because in this position the restoring torque will be 0, potential energy will be minimum. So here torque is 0 and U is minimum. Now we displace this pendulum by an angle theta, and then we try to find the restoring torque. Theta is small, but in the diagram we are drawing it big so that we can see everything clearly. So here in this position, the weight of the bob will act vertically downwards, mg. This mg will have two components. One in this direction, we can resolve this mg into two components. So this is theta, this will also be theta. So this is mg cos theta. Mg cos theta will be balanced by the tension in the string. This mg sin theta will be acting in this direction, and this can produce a torque about the point of suspension. This torque is given by force into perpendicular distance. So this mg sin theta into L is the torque. This torque is opposite to theta. Theta is that way, the torque is this way. So therefore, the torque is restoring torque, and torque will be equal to minus mg sin theta, because torque is opposite to theta, into this distance, that is L. Right? So torque is minus mg sin theta into L. Now we know that torque is I into alpha. F equal to ma. In rotational motion, F becomes tau, m becomes I, and a becomes alpha. So torque is nothing but I alpha. So I alpha will become minus mgl sin theta. Now if theta is small, torque is proportional to minus of theta, because when theta is small, sin theta is approximately equal to theta in radians. So if theta is small, typically we say less than 6 degrees, then torque will become minus mgl theta. Torque becomes proportional to minus theta. Therefore motion is SHM. So now we have proved that the motion is simple harmonic if theta is small. Now from here we can get alpha. Alpha is tau by I. So alpha becomes minus mgl by I. And sin theta is approximately equal to theta, so minus mgl by theta. And in SHM, angular SHM, this is minus omega square theta. So omega becomes root over mgl by I. So omega is root over mgl by I. And the moment of inertia of this bob about this axis, which is the axis of rotation, okay, is m into L square, mass into distance square. So mgl by ml square. So m gets killed, 1l gets killed, so we get root over g by L. And now we know that omega is 2 pi into frequency, that is 2 pi by time period, and therefore time period is 2 pi by omega, and 2 pi by root over g by L, that is 2 pi root over L by G. So this is how we can find the time period of a simple pendulum by restoring torque method.